All right. I think we can now start now. Let me try and share my screen. So we have started exploring Langchain in the previous coding session, and we are just going to conclude that session with today's session. It's a very small, session. Today's session is going to be very small and quick. Hopefully, we have tried to explore the previous code and then play with it. But in today's session, we'll be moving to something different. We have talked about all the components of Langchain and how these components come together to make it function. We examine the major components that we have: template agents, vector store, chain, memory, and the rest of them. And we demonstrated some of these concepts in code. Now, today we are going to be dealing with what we call program-aided language model. And then this concept talks about using a language model. It employs LLM to interpret natural language problems and produce programs as intermediate step in reasoning. What this means is that if you are using program-aided language model, it means that this concept will make use of large language model that we are familiar with to interpret the our natural language. For instance, if I want to find the area of a circle now, let's assume that I want to find the area of a circle. I will pass that through a large language model using ChatGPT API or using Hugging Face, for instance. Now, if I pass this statement, it's a question: get me area of a circle. The large language model is going to act like a programmer and try to write the series of steps that will be used to calculate the area of a circle. That's what this concept is talking about. Program-aided language model tends to act like a coding, it's more or less that we are using LLM to generate code. So the steps or the syntax that is needed to build the area of a circle will be written by the LLM. So he said that the method diverges from chain of thought because we experimented and then play with chain of thought in class. Chain of thought just wants us to on how to perform a particular task. For instance, if I want to check from series of numbers or sequence of number which one is odd or which one is even, then I'm going to be writing this series of number, then give it some examples. This number that are 1, 2, 3, 1, 2, 5, 5, 5, 7, 8. Then these are the even, and do another example like that and so on. That is chain of thought, which we implemented in last class. So we are using words to implement chain of thought. Of course, this also has some reasoning. So we are the one explicitly writing the reasoning in chain of thought. But in programming aided language model, the LLM is going to write the chain of thought to implement a particular concept or a particular problem we are trying to solve. That's what differentiates it from chain of thought. And I think this is the major concept we are dealing with today. So, in continuation, he said, as it doesn't rely on giving tests to derive solution, instead it outputs solution in programming syntax. So let's see this in action. What I'm trying to say, let's try to explore that in code. In today's implementation, we have some a library that will be imported to explain or to demonstrate this. Then afterwards, So we have some other library that will be used also: OpenAI, OS for directory, IPython for Python interpreter, and the rest of them imported. As usual, I have used my API key here which will be used in this code. Then I create the chat OpenAI model with the parameters that is needed. Temperature is set to 7, which gives no randomness in its output. Then the model name, I'm using this model name, and I put my API key there. So this creates what we call the object of the class chat OpenAI, store it in a variable LLM. Then, of course, I want to solve a question. I want my LLM to act as a programmer. So I'm giving it a structure here. In this question, I said, what is FVS? What is the FVS penguin, for instance? Then I have a prompt. These three, when you want to have series of prompts, I mean, series of text, then you can put that series of text in these three quotation mark also. Then, of course, I have this prompt structure like this. It means that the question that I gave to it is going to be taken in by the LLM. Then I want the answer to be in to be commented in the code. That's why I put this. I'm canceling that. That's why I put this. Then I strip any straining space on the right or the left. This one is just to remove any elongated space on the right or on the left. Then, of course, I want this one is stored in everything I've written here. I store it in a variable penguin font, and I give it format to put question as question. Of course, I want it to be output as human message. Then again, and I pass the LLM that has been created, the object of this chat OpenAI. Then I'm passing the message that will be generated um, by the LLM. I pass it in this list. Then, of course, I get my output. So I just asked a question. I said, what is the AVS penguin? Then the LLM is going to act as a programmer. So the programmer LLM is saying that it's setting a variable, Emperor Penguin 44. It sets another variable for King Penguin 16, Adele Penguin 11. Is one that is bringing the logic out itself. It's even from the chain of thought. In the chain of thought, we are the one that will set the logic with words, with text. But in this case, it's the one that is setting its logic, is the one that has chosen the number, I mean, the value for each of the variables that it wants. Then after that, he used the mass function in Python to find the maximum among the three, of course. Then it's setting that in AVS Penguin, and it's printing that out. I said you should comment this out for me. You should tell me that the output that I will have when I run this code is the AVS Penguin. And of course, I executed the code with this command. Of course, the largest out of this number is 44. So the point is that when we are implementing this type of concept, we are just giving the power to code a logic or question that we want to solve to the computer, to the LLM in particular. So we are basically using it for code generation. So the same code, the same line of code is used in this second example, but in this case, I am using different, I'm asking another question entirely. I am asking that, how can I calculate the Pythagoras theorem? Because, okay, I'm using this example because they are mathematics examples, so it can actually explain, and the response is going to be logical. It's something that we can relate with. So the same steps is followed. Then the LLM decides to implement that. How can I, calculate the Pythagoras theorem for mathematics? Hypotenuse square equals to opposite square plus adjacent square, the size of the right, I mean the sides of the right angle triangle. So it imported a library that will be used in this case, which is math library. Then it defined a function, and that function, it said, is going to take two arguments, two parameters. Then it uses square root, because if you normally calculate the hypotenuse, you take the square root of both the opposite and adjacent, and that's what it does here. Then it returns the output. It is now giving me the output, I mean, as a comment, which is what I asked it to do. It commented this using an example, side one, side two. Then the hypotenuse is called the function, and the two sides are put there. Then it prints it out. Then, of course, I executed that function with this command. then I strip any trailing space. Then I have the length of the hypotenuse is 5. Definitely from this example it has used, must have used this example that we have here. 3 square plus 4 square, that is 9 plus 16. And I think that's 25. Square root of 25 is 5. Then another example followed the same implementation. I'm just asking another question that can be a little bit tougher here. I'm trying to ask it to calculate the integral of a triangle and return an answer. Then the same step, the same series of code implemented. Then it thinks on its own how to implement it. It write a function and it call it a name. It has base, it has height. Then it calculates basically the area of the triangle, because the question I asked it is calculate the integral of a triangle and then return the answer. So it does that and it calculate the integral. Following this step, I don't even understand. I don't even remember the mathematics implementation of this myself. So it has the base, that's the height, then integral, then it calls that. So basically, the integral of a triangle is the area that the triangle is bounded with. Basically, yeah. So implementation, then we have the area of that triangle to be 25. The same logical question, we also follow this same logic. It's more or less like the LLM is acting as a programmer and generating the logic itself and implementing it itself on its own. You can ask any logical question and it's going to follow the same paradigm of implementation. I think that's all that we will explore this time around, because I think that covers the material that we have. In case you have any question, contribution, or otherwise, before we go. Yeah, it's half base times height, of course. That should be the area of a triangle. Uh, Katia, we like to say one or two things. Tanisha, we like to say one or two things before we call it a day. All right, no question. So, Amoye, I think we are done.
It's all right. Thank you so much for the session. Goodbye, everybody.
Yeah.